goes to our esteemed dean, acclaimed alumni, respected HOD, and all students for gracing us with their presence. I am Ilakya Visahan and this is Akansh and we will be your host for the day.
A revered alumni of NIT Trichy and Google's chief business strategist for AI, renowned for pioneering initiatives in brand marketing and AdWords, Mr. Gopinath Sir's transformative expertise shapes global business landscapes. His journey from NIT Trichy to the Wharton School of Business reflects his dedication to excellence.
We are truly honored to welcome Mr. Gopinath Kallayil, a proven industry leader in the field of AI and a catalyst for impactful change proven by his stellar track record.
It brings us with great joy to share the stage with such an esteemed alumni of our institution, who has embarked upon many ventures in the past, reaching great heights. Now off to you, respected sir.
All right, thank you. Good afternoon, everyone. One second. Can you hear me now? No. Audio, yeah? Am I live? This is... Check. You guys hear me at the back? Oh, okay. All right, so let's do this to get this started. If you are sitting in the last 3-4 rows, please stand up. Okay? So the last few rows, enough. Everyone stand up. So I'll come and guide you up till, this point. Everyone down this row. Stand up behind this, okay? And everyone down this row also. All of you stand up and come into the center aisle. We're just going to disrupt things a little bit. This is how we do it at Google. So if you want to have a Google lecture, so come into the center aisle, quick. Okay? And now walk forward, right down the middle. You shouldn't be shy. You sang today for me. Come forward. Yeah, this is what I'm going to ask you to do. Step all the way forward. Guys, right here, sir. And now fill up the first 3 rows because I want people out in the front. Okay, I want like a full house right in the front, so more intimidating. Some of you are backing up. No, you guys, wait, you can't do this to me. No, I've come all the way to talk to you, so you come all the way to listen to me, right in the front. What's your name? Oh, what's it? Mugilan. So Mugilan, I want you right in the front. Find Mugilan a chair in the front. Thank you so much. This is much more intimate. The rest of the people who come late can join in the back. So I find it interesting that there are 50, 60 of you here to listen to me. I have to give you a disclaimer. If you do the math, you'll realize that I graduated in the last century. So I should be the last person you want to listen to when it comes to AI. But here's an interesting fact when it comes to AI. This has been a field that has actually been around for 60 years. When Mike Murphy at Dartmouth University called a conference, he was famous for information, and he coined the term artificial intelligence. In fact, the year I graduated, around 85, something seminal happened. You guys all good? Yeah? Everyone settling? Okay. Yeah, I'll just wait for the last minute commercial then. You guys good there at the back? Okay. So, 85 graduate, 86, young cognitive psychologist called Jeff Hinton wrote a paper on a topic called back propagation. Okay, it happened back before you were all born. And for most of the world, it didn't mean anything. A few people in computer science actually dismissed it. But the reason I bring up the topic, and it's coincidental to when I graduate, is that back propagation paper actually became the foundation for what we now know as neural networks. And Jeff Hinton, the person who wrote it, would go on to work at Google. And little did I know that when I was coming out of RAC, that this paper on back propagation would be the fundamental building block of a lot of things we know in computer science. It is the underpinning of neural networks. And Jeff Hinton would be someone who would wear the same badge as I'm wearing. He left Google recently because of very specific reasons of what he thinks AI will do. So it's interesting that all of this is coming together. But we are at this incredible point in history where AI is suddenly breaking out from theoretical concepts, a laboratory, to actual consumer usage. And every technology has a breakthrough moment. And in our lifetimes, we've had the privilege of witnessing it. Probably not in your lifetime. So, at the average age, you're under 20, right? I assume, yes? Yes, or just about 20 or so. So, at least in my lifetime, since REC, I had the privilege to witness 3 big technology shifts. And the way the world works is every decade or so, we see a major shift. So in the 80s, when a lot of us were graduating, or subsequently, for the first time, computers left data centers, started showing up on a desktop. But these computers couldn't talk to each other, they were standalone. And then in the 90s, the internet, as you know it, just started getting used by consumers. And what made that usage possible, if you looked at, for you it'll be history, for me it was my life itself. What made it possible that ordinary consumers could suddenly start using the internet? What do you think? Take a guess. There's one piece. Your parents being able to use the internet all of a sudden and being able to book tickets and buy milk and call a taxi. What's that? The browser, exactly. In 1994, the Netscape browser was created, and all of a sudden, ordinary people outside of research labs could use the internet. So that was the big leap in the 90s. And then in 2000, one more shift happened. So in the 90s, you could use the internet, but only on a desktop. In 2000, that changed. What changed it? What's that? Mobile, exactly. That was 2006. I remember when we were at Google, a bunch of us were told to go wait in line outside the Google store all night so we could buy the first iPhone and come back and test it. That was 2006 when the activity shifted to mobile. So that changed again the computer paradigm, and then Android came, and now we have, 8 billion mobile devices in the world. More mobile devices than humans. For the first time, we've had that in entire human history. And then, so that is the second big shift. And now, we are, it's not thunder, is it? What's happening? Oh, the AC is blowing into my mic. What is that phenomena called? There must be a name for it. This is incredible. Okay, so I shouldn't go to that side, right? Okay, all right. I'm sorry, people, but I won't be talking to you. So now we are seeing this. So congratulations. In your lifetime, just as you're graduating, this is the next big shift. And this is not only the next big shift. In my mind, in all of Google's mind, including Sundar Pichai, our CEO, who always says, this is the most profound technology that human beings have ever created. It sounds like a lot of hyperbole, but if you look at it, once in a century, humans come up with a piece of technology that completely changes the arc of civilization. For example, in 1470, it was Joseph Gutenberg creating the printing press. That seems like a long time ago, but still, we have printed books that determines how information is disseminated and published. And then around 1672, it was the discovery of electricity by Benjamin Franklin, when I was talking to Professor Selvaraj about it, and he was explaining exactly when it happened, and he was giving me a little bit more understanding of. By the way, if you've known it, one of our most hallowed alumni is here. Just put your hand up, sir, and his wife. From the third batch of REC and still teaching at the California State University, electromagnetic radiation, and his wife, I want to welcome her also, Kalyani. Phenomenal. So electricity, and then in 1892, it was the invention of the automobile. So once in 100 years, we come up with something that changes. And now AI is the next big shift. And congratulations, it's happening, meaning ordinary consumer usage of AI, just as you're graduating. So I spend a lot of time, much like you're all curious. My job at Google is to meet with the CEO, CMO, the biggest 1,000 companies in the world that are Google customers. Could be Unilever, could be Procter & Gamble, could be Volkswagen. And all of these leadership of those big global companies are trying to understand, what is this thing called AI? How will it affect my industry? What do I need to know? How do I work with Google? So I'm going to give you a version of a presentation I did actually to executives at Apple Computers to explain it. So this is the conversation I'll have. So in my telling, it'll have a lot of business perspective because that is my typical audience. How a business leader should understand AI. But before I do that, I always ask this question. This is the question I always get when I meet with the leader of any big company. banking and insurance and auto. What is my AI strategy? They tell them that's the wrong question to ask me. Because you don't want to start with AI. Instead, I tell them, strike that question off, and I want to know, what is your strategy, period. What is your business strategy? Then let me tell you how AI can enable it. Because then you will get to the right answer. Otherwise, what many companies are doing currently, a terrible mistake, look at some aspect of AI, and they see it's a shiny thing, and says, let's implement it, before you even know what is the biggest benefit that they can derive. And for business to business, it changes. So this is my way of changing the thinking and saying, let's start with your strategy, and then let me tell you how AI will enable it. Or another way of looking at it, I look at these C-levels that I'm talking to and ask them the question, what is the biggest opportunity in your business for 2024? And then let's see how AI can be used as a tool to enable that. And the reason I'm saying this is for the kind of audience I speak to, they spend a lot of time thinking about not technology, but other aspects. You would realize it when you start working. So for example, I had a meeting at the Google headquarters with the leadership of Nestle. You know the company Nestle? Okay, what do they make? Chocolates, what else? Coffee, water.
FMCG products.
What's that?
FMCG products.
FMCG products, and all consumable. Everything goes in your body, all of the products you eat. So I talked to the leadership, and before the meeting I asked some people, and there were a couple of gentlemen, both who happened to be Indian, and I said, what is your focus? And one guy said water, and the other guy said his milk. Milk-based products that Nestle makes. They spend all the time thinking about new kinds of water, new kinds of milk, how to market it. They're not thinking of technology. It is our job as engineers to kind of help them understand. In my case, it's about AI. How do they use AI to effectively sell milk to you or water to you? And that's why I always say, let's start with your own strategy. But at the same time, many of these business leaders also have a lot of fear of AI. How many of you, besides excitement about AI, sometimes worry about it? I got at least 2 questions in the hallways today. Any of you nervous? Yeah, you can be honest. Yeah, you asked me, right? This morning question, and remind me your name one more time, you mentioned it, from Kashmir. Raihan, yeah, sorry Raihan. Yeah, Raihan and Sajjad asked me this question. So this is very common, and you are not atypical, and I want to show you that sentiment is captured in this cover story that came out in The Economist, and I'll put out this cover story here. This was the cover story. By the way, you know I was educated in the last century, walking around with a tattered copy, print copy of The Economist. So forgive me for this, but I like this cover. Actually got several copies. I even framed this and put it up, and you can see it from there. This is the design. So that's a halo about the A. That is the promise of AI. There's devil's horns and tails under the I, the perils of AI. This beautiful design, in my mind, epitomizes the feeling most business leaders have today. So if you raise your hand saying, I'm nervous about it, you're not alone. So let's start with what I usually do, which is demystifying AI. Kind of let's bring it down to a level where we don't have to fear it because we understand it. It's when we don't understand this technology. I believe all of you use some conversational AI tool. Like, how many of you use ChatGPT? Do your exams and homework? Yeah, so most of the class. It's good, congratulations. No, that's the right way to do it. This is the best way to learn about it. How many of you use Bard? Just curious. About half that audience. That's good. We won't change it to full by the end of this conversation. I need it. But how many of you also know what is going on with the underlying technology? Like how exactly does machine learning work, large language models, etc.? You just use it, right? But do you know what's going on under the hood? No. So shall I take some time to demystify and explain? Just about 4 or 5 slides. The same level at which I use it to explain it to, again, business leaders. So Kalyani, you asked me this, I hope, and if it's not up to the level, please tell me to deconstruct it. So what exactly is AI? And before I talk about AI, I want to talk about what I call NI, or natural intelligence. I'm looking for something to show here. Let's pick up my bottle of water. Product. And I want to use this to explain a fundamental capability of human beings called natural intelligence, NI. If you look at this, this is incredible. Only human species can create it. There is metal here, the concept of purified water, printing on it, color red, pricing, distribution, marketing. There's so much of human intelligence that goes into one simple, humble product, a bottled water. The same goes for the t-shirt you're wearing, the shoes we wear, the ceiling, everything around this room and around us is really the creation of what I call natural intelligence. But natural intelligence is limited and starts hitting constraints. For example, if I go back to that Nestle example, the Nestle leadership, the C-suite might be 20 people. So I have 20 very smart executives, but only 20. They go to sleep, they need vacations, some days their brain doesn't work so well. So this has been a challenge. In fact, today, if you attended the talk, Dr. Bhaskar Bhatt, who used to be the chairman of NIT, the supervisory board, he talked of the problems that exist in the human condition in India. So to solve all of this, we need not just 30 brains, 300, 3,000. This has been a quest of the computer science community. How can we take this incredible talent, say in this room, all of your natural intelligence, and amplify it, not replace it, amplify it. And this is what really artificial intelligence is trying to do. So the definition of artificial intelligence, according to Google DeepMind, is simply this. It's any computer system that is mimicking natural intelligence, right? A computer system that is designed and trained to mimic natural intelligence. And when we do that, we can now amplify it. We can put thousands of computers. So it does not replace the human, it is needed, but now it amplifies it. The analogy I want to use is that of the bicycle. And I see a lot more bicycles on campus here than there were when we were on. Most of us couldn't afford actually a basic bicycle because of our financial circumstances those days. But if you look at human locomotion, we crawl first in our parents' living room. Then we learn to walk unsteadily. Then we run. And then we hit limits. There's only so far you can run, so fast you can run. And the day your parents put you on the bicycle and taught you how to ride it, you use a simple device, 2 wheels, a gear system, and a saddle. You use your legs, the same legs you use for running, but now you're using it differently, and you go further and faster than you've ever gone before. It amplifies human locomotion with no external power. That's what we're trying to do to our brain with these artificial intelligence systems. So we shouldn't fear them, we should welcome them. Of course, there are some risks, etc. We'll talk about it. So an example, 2 examples is artificial intelligence systems like translation systems that are point solutions. They do only one thing and they do that very well. So here's an example. On this phone, I have Google Translate. Assume many of you use it. You use Google Translate, play around with it. I use it. I travel around the world. I'm in countries where I can't communicate with the maid or the taxi driver. And check. I think I've gone off, right? I'll let them fix it and we'll continue working. So if I'm in Japan or Brazil and I need to speak to someone in Portuguese, I use this. And if you don't know, Google Translate can actually translate in 144 languages, including Serehi, Tui, Guarani, Maitonin. I didn't even know where these languages are spoken. Yesterday I was flying in, I was at the Bangalore airport, and I met these young women who were working there at the lounge, and it turned out they spoke Maitonin. It's a language spoken by about 1 million or 2 million in Manipur, so it's the Manipuri language. And I use this to translate, and we're able to communicate. So it has amplified my ability to communicate to 99% of the world's population, right? It amplified me. It did not replace me, I'm still needed to communicate. That is one example. Or take health AI systems for diagnosing health conditions like MedPalm from Google. It actually can diagnose with 85-90% accuracy certain medical conditions. And you would say, would that replace a doctor? No, it does not. It amplifies a doctor's ability. So I'll give you an example. Today, if you're trying to see a specialist in the UK health system, sometimes it takes 6-8 months because many specializations are in shortage. Or take people who, ophthalmologists who can detect conditions like diabetic retinopathy. Many parts of India, we only have one ophthalmologist for, let's say, 200,000 people, when ideally needed for 20,000. So we can use these med systems to take a picture of someone's eye with their phone, and the system will do the initial detection and say that these 3 people are more susceptible to that condition and let the doctor see them first. So a lot of things like that we can do to actually bring healthcare to people. So think of AI as a system that actually will amplify many of the things we can do in the human condition. So if they mimic the human brain, they also mimic the two sides of the human brain. So let's imagine that this room is more right brain thinkers and this side is left brain thinkers. Okay, my right, my left. So what is this room more capable of? If someone says you're a right brain thinker, it means you are more creative, and left brain is more logical, analytical thinking. And AI systems actually fit into those two buckets. Okay, so think of it as right brain kind of AI, and that is what the world is now calling generative AI. You probably have heard the term. So this is AI systems that can create music, art, text. It helps you do your tests and homework. It can actually generate code very well. And there are AI systems that mimic the left side of the brain, this side this side capability, and those are analytical AI systems. And between these two AI systems, we now have 4 capabilities. So when I talk to Nestle leadership, I said, this is what he can do. He can synthesize vast amounts of data and look for patterns. It can make predictions very well. It can look at huge amounts of data and predict certain things. And sometimes, even incredible things that would be hard for humans to do. For example, one of the most complex things to predict that we haven't solved for is the weather. Predicting the weather is very hard. So we have a medium-term weather forecasting system, and most of it has become sort of a weather prediction lab in Bologna, Italy, and it uses a very complex equation. Last week, Google announced an AI-based weather prediction system that is more accurate than any that we have seen. It's called GraphCast. You can play around with it. It's open source. We give it away free. And it predicts weather up to 10 days using machine learning more accurately than anything humans have seen. So this could actually change everything from agriculture to air traffic control to disaster planning. So that's the second thing it does very well. Third is create content. And this probably the world knows. You played around with it, right? You get in images, or you can create music and art with AI. And the fourth area is conversations. This is the one that most of the world thinks of as AI. For most of the world, it says, do you use AI? They'll say, yes, I had a conversation with ChatGPT. But remember, that's a very narrow corner of the world of AI. There are a lot more things. 2 more definition slides, and then let's play around with some demos. So often I'm asked the question, so what is machine learning? What is neural networks, etc.? Large language models. So a simple way to look at it is, again, our first definition, AI mimics the human brain. It's a broad field. There are many ways to achieve that, to get to AI. One of the ways, techniques, is machine learning, where we look at vast amounts of data. You don't have to tell the machine anything. Yes, I may be doing it. And it learns just from the amount of data. This is like how human beings, for example, farmers, right? Farmers who've been cultivating maize or something, over a long period of time, they look at a lot of data and information around how things grow and pest and weather and rainfall, etc. And they're looking at the patterns, and the brain starts recognizing. After a while, after 20 years of farming, they can accurately see some things. So it's not specific training, it's pattern recognition. And machine learning tools do something similar. So it's a subset of our AI, and within machine learning, there's a subset, generative AI, which basically works with creative content, the right set of a brain, and creates new output. So this is how image generation tool works. We expose them to 10 million paintings, pictures, photos, and then you tell the tool, paint me a picture of a cat in the Rembrandt style, and it's able to do it because it looked at a lot of data, machine learning, patterns. I want to explain one last thing, and then we will get onto it. This is a term everybody's throwing around. Okay? How many of you feel confident I can explain exactly what a large language model is if you have to be interviewed for a job tomorrow? Anyone? Right, everyone is hesitant, right? You guys are smiling. What the heck is a large language model? So I'm going to explain this using someone here as an example. What's your name? Sorry? Valerie. Valerie, do you drive? No. So I'm going to use Valerie as an example of how her brain development takes place. May I? Yeah? Use as a reference. Thank you, Valerie. So when Valerie learns to drive, whoever is training, let's assume her family, they will actually explain every instruction on what can happen on the road and what she has to do to respond. This is how traditional programmers used to write programs. So in this case, Valerie would be told, you see a green light, do this. If you see a red light, do this. If you see an ambulance behind you with the siren, then you take this behavior. If you see a stop sign, this is what you do. And if you are confused and it seems unsafe, the safest thing is slow down, pull to the side, and come to a stop. Now Valerie knows how to, Valerie, right? Vallari? Okay, yeah. My mouth's going towards saying Valerie, but it's not at Valerie. So Valerie now knows every single thing that can happen and how to respond to it. This is how we build traditional programming, where if you have to write a program to recognize a cat, you have to define all aspects of a cat and had to code it line by line. And then the computer knows how to recognize a cat. From that evolved a concept called neural networks. So again, let me use Valerie as an example. So as she's growing up, her parents would have pointed out to her saying, that's a cat. This will leave, you can totally do, I won't be offended. You didn't realize that you had gone over time, my apologies. Let's look at image generation. Okay? Again, these tools are trained, they're machine learning tools. And imagine this one, a chrome-plated duck. That's what I want you to imagine. Not any duck, but a chrome-plated duck. It's got a golden beak, and the duck is arguing. It's arguing with an angry turtle in the forest. Kind of a ludicrous image. How long will it take for you to imagine that? And anybody here is a painter? Any painters in the house? How long would it take for you to paint that image after you imagine it? 13 hours? 2-3 hours, right? Yeah. But now these tools they're so versatile, you just give it in 3 seconds, they can actually, if the clicker works, boom. From here, the image gets generated. Right? Chrome-plated duck, argue with an angry turtle. So this was generated by Imagen, which is an image generation tool. And let's actually watch it being done live. So I'm going to Imagen, and let's generate some images here. So you're looking at a photo of a corgi dog, a Shibuya dog. But instead I say, I want to see an oil painting. I'm prompting it. And an oil painting of a raccoon. And the raccoon is wearing a cowboy hat, but I wanted to wear a red shirt. Okay? So the tool understands me, and I want it not on a skateboard, playing a guitar. Playing a guitar is currently in a garden, but I want to see it on a beach. Or, no, not otherwise, raccoon with a red shirt on a beach, and let me put it on top of a mountain. So you can see how versatile the tool is, right? It generates images because it's looked at. You might say, so what is the actual use case of this, especially when I'm speaking to a business audience? It's all fun and games. And this is where, if I were talking to L'Oreal or Procter & Gamble, I'd show them what we do with these kind of technologies to help them. So if you are a marketing manager for, let's say, an exfoliating cream, let me put this off. Okay, so if you're a marketing manager for a exfoliating cream, let me see if I have one in my bag. Sometimes I keep one. No, I don't have one. So you'll have to imagine it. Okay, so let's say this is a tube of exfoliating cream. Your job as a marketing manager might be take a picture of this and show this in different settings. For the holiday season, we are going to do a campaign, a digital campaign, and then we sell in 40 markets around the world. So we want it in different contexts because the Russian market is different from the Japanese market. This is what marketing managers are often asked to do when you launch a new exfoliating cream. But now we can help them speed up the process by using tools like the one I showed you, the raccoon generation tool. So one of the tools Google has is called Product Studio. So this I'll give you a demo of Product Studio. So imagine your job is to do a marketing campaign for exfoliating cream. So you load the tool, and you first take a picture of the exfoliating cream. It's in your product catalog. You just point your camera and take a picture, and then you say generate scene. And then you describe in words the scene, just like you did with the raccoon. So the description you may type is, I want to show a tube of exfoliating cream on a stone platform surrounded by peaches with tropical plants in the background. And the tool generates different versions for you to take a look. And it's it. Now the marketing team looks and saying, no, not so good. Let's change the background to a beach. And instead of photographing the tube in a beach, you just change the words. Instead of forest, you say sandy beach, regenerate, and now it comes back with the picture of the product and a beach. So now we can discuss it, try different concepts, test it out, see which one the audience responds to. It changes how the world of marketing could work. So this is an example of it. Think it's cool? Like it? So all of you will have cool jobs in the future. Let me now give you another demo, music generation. Okay, music is a completely different format. I'm a musician. I do kirtan. That's the genre I'm drawn to. I have 3 albums. I was in the Grammy 2 times. It's only on the ballot. I didn't win it. But one of my frustrations with music is I can imagine it in my head, but I can't make it come out through a harmonium or a piano or a guitar. I go to my producer. He will create. Then we listen to it and then say, let's change it a little bit. Bring in a certain musician, add more tabla or an opera singer, and then we generate another version. So we go back and forth. It takes us about 3 years to do a single album. It's a slow process. But now all of that can change very dramatically because these tools can accelerate my ideation process. So one of the tools is Music LM. By the way, everything I show you is available to you, and you should be playing around with it all the time. This is the best way to learn about AI. So I showed you Bard, it's available to you. I showed you Imogen, search for Imogen. There's a research paper and demo site, play with it. Music LM is also available in something called the AI Test Kitchen, which is where Google puts out these products for you to test and play around with. So these are not fully released products. Okay. It's good, Valerie, you're shaking your head. So you're going to try AI Test Kitchen, right? Take it for a test ride. I think safe. So let's do AI Test Kitchen test drive. All right, let me create some music for you. Since I'm here with you all, I want to create some fusion music using Indian. And let's say, Krishna Kumar, let's flamenco. Okay, let's go with flamenco, which is music that you hear mostly in parts of Spain, in the Barcelona area. Let's mix the 2 genres. Oops, can generate audio for that. Normally it does it. Flamenco. Fusion music between. Did I spell anything? No. Oh, I didn't see INDA. I'm wondering whether it's blocked here because I'm in India. Normally it works in the US. Let me try something else. Fusion music. Oh, let's try this one. Soulful jazz for dinner party, since it's an existing prompt. Can't generate audio. You know what? I think it might not be available in India. That's what I'm thinking. I've never happened. Let me try any of the bubbly, optimistic cyber. Okay, I cannot demo it because sorry for that, sorry to disappoint you. But I would have been playing around, type different words, add a tabla, add a saxophone, etc. And it would have shown me a version. But I'll actually show you a version that a company created, Cadbury's did with this kind of tool. So you'll get an idea with that. This, I believe, went viral. Have you, anyone here created the birthday song using Cadbury's site? Anybody? You did? What's your name? Shartaj? Shartaj. Shartaj is that. But most of you are new. You want to see the demo? Okay, I'll explain the concept. So Cadbury's knows when it's your birthday, people will buy a box of gift chocolates and give it to you, and then everyone sings happy birthday to you. It's the exact same song for everybody, everywhere in the world. Sometimes they change the language. So Cadbury said, in the age of AI, why should it be? If it's Sartaj's birthday, she should get a unique song. And your name? Abhishek? Yeah. And if it's Abhishek's birthday, let's ask Abhishek what is he interested in, what are his passions. We should give him a unique song. Why we can't do this? So they created a website where you can do it. So if it's Sartaj's birthday, you buy her a box of gift chocolates, please do. When is your birthday? Off? Oh, wow, it's tomorrow, day after. All right, will you all please buy a box of chocolate for Sartaj and create a song using the site, okay? Sartaj, your classmate, you can tell on 14 who your best friends are. I hope you get 100 boxes of chocolates from SE. So you go to the site and create a song for Sartaj by typing in a few words about Sartaj. Here's a demo of that. It's Tinku's birthday, not Sartaj's.
Thank you.
Is it फिर my birthday song?
Correct. Happy birthday Tinku ji, mighty वाले Tinku ji, ऑफिस के सितारे सबके दुलारे हमारे Tinku। Happy birthday Tinku ji.
टिक्कू जी मेरा भी सुन लो आपके लिए बर्थडे सॉन्ग टिक्कू तैयार पार्टी है पार्टी है
So you can see Tinku gets like a dozens of songs. This is how companies are imagining what they can do with generative AI capabilities, in this case music, to do amazing. So this has gone viral, I was told, in India. A lot of people are using it. A couple of more quick demos and then we'll wrap this up. And again, if you need to run, I would not be offended. So I'm going to show you this concept we thought about at Google. Okay, so I can go from text to text, text to images, text to music. What about text to video, where I can do a script, right? Movie directors will write a script, and then you have to film it, bring a film crew in, and they follow the script. What if you can automatically use AI tools to generate the whole video just by feeding it a script? So we built a tool called Finaki, and I'll give you a demo of Finaki. I'll play a video since I won't. This should work here. Wi-Fi still on. Okay. This again.
Blue balloons stuck in the branches of a redwood tree.
So here's what's going on. So this is the script. Imagine you are the video director. This might be the script you wrote. And right there is the video that the tool is generating. Don't worry about reading it. Somebody will read it out to you. In fact, it's not just any somebody. It's Douglas Eck. He's our VP of Engineering for Generative AI Products. So Douglas is reading the script, and here is the demo.
Camera pans from the tree with single balloon to the zoo entrance. Camera pans to the zoo entrance. Camera moves very quickly into the zoo. First-person view of flying inside a beautiful garden. The head of a giraffe emerges from the side. Giraffe walks towards a tree. Zoom into the giraffe's mouth, of course.
As you can see, this is all AI generated. In fact, if you look closely, where was the giraffe? It does not look, see that, its body? Because the AI tool is not perfect. We'll figure the problem, but it looks like a very mutated giraffe. And, but the fact that it can even get to this stage is pretty astonishing. And using enough computational power as well as making the algorithm better, we will soon have very realistic kind of images. Again, you might ask the question, this is good, but how would you use it? Especially to the business audience, I have to show Cadbury's or Honda, what will you do with a tool like this? And let me show you what many companies are doing. Here's an example. And this is what Cadbury's did.
Zoom into the giraffe's mouth, of course. Blue balloons stuck in the branch.
Have any of you know the Cadbury's campaign for Shah Rukh Khan Diwali? Yes, some of you. Is there anyone who has not seen it? I'll play it then in that case. Everybody seen it? The whole class? Okay. So you know what they did, right? How they used AI to read his face, and then he will talk to each of you and say, this Diwali, buy Cadbury's chocolate from RK Sweets, which is in your neighborhood, or Lakshmi Sweets, which is in your neighborhood. And that way they were able to customize it. And just in case, and maybe Silveraj, you may not have seen it, right? Living in the US. Silveraj, have you? Let me play it for him. You know, Kalyani and Silveraj at least, and there might be 5 or 6 people. Just 10 seconds.
लाया हो ना यार अपने पास वाले रोशन किराना से आप भी अपना मीटर वहीं से लें
We used machine learning to recreate Shah Rukh Khan's face and voice to take the local store names in the ads.
इस दिवाली आप भी ना अपने पास वाले चॉइस ऑफ फैशन से ही कपड़ों की शॉपिंग करना पास वाले आजकल फैशन से ही रॉयल फैशन से ही एमके क्लॉथ से ही पास वाले लक्ष्मी कलेक्शन से ही कपड़ों की शॉपिंग करना इस दिवाली आप भी ना अपने पास
Different versions of the same ad with local store names were targeted as per the PIN code of the viewer, showing them only the nearby stores. But it is impossible to cover all the stores. So we gave the power to the people to create their own version of not just a Cadbury ad. Any small business owner could promote their stores through their own social media networks like WhatsApp.
Again, the idea is you film Shah Rukh Khan once and then say, repeat the ad with different store names, and then thousands of versions are created using AI. And to you, it looked like, yeah, he's saying the name of the store in your neighborhood. So this is actually a use case of going from text to video. And a lot of companies are excited about the possibilities of it. So I'll tell you a practical use case. How many of you, your family has a car and seen a car manual? How do we get it? Yeah? How many pages is a typical car manual? These days, cars are very complex. They're really computers on wheels. Take 400 pages. Who reads those manuals? What you do is, when there is a problem, you look for a 1-minute video on YouTube that explains that particular problem, like how to unplug the charging port of my car. You just want to know this. So car companies are racing to create thousands of videos that explain different aspects of the car, so when you look for it, you get it. It's very hard. It takes a lot of time and money to create this. And they're hoping that using technology like this, they just throw the manual at the AI tool, and the AI tool will read it and creating short videos that explain all of this. And this might be the future. Everything I showed you so far works on things that can be digitized. Text, video, audio, music. But the world we live in is not digital, right? It's very physical. There are things here like cameras and things. So how do you come up with AI systems that can actually interact with the real world? It's a question we are now asking. So we are experimenting with it. So what I'm going to show you now is very experimental, just to see how we are thinking about it. So here again, if I were to use Valerie and take her to another environment, let's say move her to another country and put her in a conference room in Sydney. Have you been to Sydney? No. So in Sydney, things would be different. But she will be able to figure things out because she has a large body of knowledge about how to manipulate physical things like the faucet and the room and the door handle in a completely new environment. She can very quickly adapt. It's a human capability. We're trying to see if we can create the same capability for robots. Today, how robotics works is we have to train them precisely. You can take them into a car factory and teach them how to weld a car door, and they will weld it 10,000 times without making a mistake. But if you say, sweep the floor and clean this room, the robot won't have an idea. You have to retrain it. But using visual language models, another extension of large language model, we are trying to see if we can actually train devices to operate in the physical world by controlling and operating physical things. Here's a demo.
लाया हो ना यार
Now this one.
अपने पास वाले
So this is a robot. It's actually standing in a micro kitchen in Google, in the building next to me. And the engineer to give it a task. The task is, bring me rice chips from the drawer. So the robot has not been trained for that task. Simply says, bring me. It has been trained on a lot of things. It has some general information. It's got a camera it can see. So using visual language model, we tell it to go grab a bag of chips and bring it back to the table where the engineer was sitting. So watch what happens. And we manipulate the environment. The robot goes, looks around, it finds something, it knows that's a drawer, right? Using the body of information. It opens a drawer, it sees a bag. It says, I think it's a bag. I think it's a bag of food. It's green in color. Okay? So it's all piece of knowledge. It stitches it together. Again, it's not been trained to do this task. So the engineer testing it grabs it away, manipulates it. It says, I can see it moved away. It takes it. It does it again. Unlike a human, it does not get frustrated. It keep doing it. Because that's what the instruction says. Grab the chips and bring it back to me. So he leaves it alone, and the robot grabs it, and the instruction is bring it back to me, right, where he originally was sitting. So if he looks for him, finds him there, drops it off, here, good boy. So, so this is just an experiment, we're playing around with this, but just to kind of give you an idea of the way we are thinking about all of this. So in the interest of time, I can go like this for another hour, but let me pause and actually explain to you. You might ask, so what is Google thinking with AI? Where are we going with this? If you were to ask Sundar Pichai, what is Google's strategy for the next 5 years, he would give you one sentence. He didn't say the sentence, but it's my interpretation, having heard and many times and spoken to him. The one sentence Sundar would say is this, that we are trying to look at 3 groups, 3 audiences, and the 3 audiences we are looking at are consumers, communities, and companies. Consumers being everyone in the world who uses any Google product, like all of you and your families. Communities being social groupings of any kind, like disadvantaged people or people with a particular language group or people who live on the banks of a river. However we define communities, farmers, etc. And companies being the big companies, small companies in the world, including institutions like NIT Trichy or Volkswagen, Nestle. So all these three groups, we're asking the question, how can we use AI to help these groups reach their highest potential? How can we help these three groups reach the highest potential? So at this point, avoiding the air conditioning draft, what it means is 4 things for Google. And this is, you'll see all of our work converging around the 4 areas. First, we are creating better consumer experiences across all Google products. So you all use many Google products. Actually, we have 15 products that are used by 500 million people or more. 6 products are used by 2 billion people. You all use it every day practically. Search, YouTube, Gmail, Maps, etc. All of these products are dramatically changing with AI embedded in it. You may not even know it, you may not notice it, but your experience will change because AI will be part of that experience. Like Google Translate or Google Maps, the reason it's getting so precise is because of AI capabilities built into it. The second is we solve big societal problems. I'll give you one example. So we look at problems in the human condition, and then say, let's use AI to solve for it. And there's no commercial intent there. We just want to solve it to make the human condition better. Third area is we work with companies and build tools to drive the growth of those companies. This is where I spend most of my time. That's the part of Google I work in. This is what brings 80% of Google's 300 billion in revenues. These companies use Google tools or do marketing to grow the business, and we are using AI power into those tools. And the fourth area is, besides marketing, companies do a lot of things. We help them become more efficient through Google tools. This is really the 4 pillars of our strategy. I will just show you one example of this, and then I will close this off because we're already well over time, and you need to go do other things. Although I showed you tools to save time, so you probably can finish your homework and test in the next 20 minutes, and you'll have plenty of free time today. So let me show you how we help solve societal problems. 1 or 2 examples. Let's skip all this. So one problem in the human condition is flooding. Half the world's population lives in a flood-prone area. India, a lot of people get affected by floods. In fact, there's one particular place where 400 million people live and extremely susceptible to floods. It's the Ganges, yeah. It is 400 million. Over centuries, they've settled there. Very fertile land because there's good soil on either side. But the Ganges River could get flooded. Brahmaputra, same problem. So the flood prediction models we have today only give you a certain limited amount of time for you to quickly evacuate. So we asked the question, what if we could triple the time? Could we build an AI model to predict floods, because there's so much of data that's available, historical information. We can use machine learning to do pattern recognition. So we sent an engineer down here to work on this, to say, work with all the data you can get around the Ganges River, the authorities who track all this, and build a model to predict flood around Ganga. So this is what they did. I'll just show you a short clip of the video. It's a 6-minute long video. It's called When Rivers Rise, How AI is Helping Predict Floods. I urge you to watch it. But I'll just show you about 30 seconds of the lead engineer, Felix, talking about it.
We're working with. We complement their effort by adding accurate modeling to that process. We start by collecting thousands of satellite images to build a digital model of the terrain.
So see, that is the key part of it. So it creates a digital model of the terrain and then runs simulations. And you can use the AI to do 1,000, 1,000,000 simulations, almost impossible for humans to do, and the AI model will do that. So that way, you can now say every possible combination of what could happen with water level, the bank collapsing, etc., and how the river will behave. This was the core of how they used AI to predict floods. Let's continue watching.
Based on these maps, we generate hundreds of thousands of simulations of how the river could possibly behave. We receive the measurements from the government and cross those measurements with our simulations. We can then send those forecasts to individuals using search, maps, and Android notifications. This is an example of an alert that we can produce. This alert is for Patna. This alert has over 90% accuracy. The lead time is incredibly important, even more than the specifics.
Any information we can give, they will use.
You want to show them the alert? Talking to people who directly experience severe floods and understanding what they really need is incredibly important for us to know how we can really help.
So this model worked very well, and we then developed it across many rivers in India. Then we built it in Bangladesh now, and we took it to other parts of the world. Now 600 rivers in the world have a flood prediction model, and the data is sent to the local authorities or directly to consumers through Google Alerts, Maps, etc. So as an example, I'll show you one more example of, again, of AI amplifying or doing some capabilities that humans could not do. So again, the idea is not to replace, but to put even more power into our hands. So we have people in the world who have a speech impediment for whatever reasons. Could be an accident, could be stroke, or morphologically they were born with a certain tongue and palate structure, and therefore when they speak, it's hard to understand them. One of those people is my friend Aubrey. She's a marketing manager at Google. And I'm going to use Aubrey to explain one of the things we're working on. It's called Project Relate. Let me search for it. Google Project Relate. We'll show an example of solving for societal problems. So this is to help people with the difficulty in communicating to other humans because of a speech-related problem. That's Aubrey. So she will explain in her own voice how, and what we built for Aubrey is actually, we built for the whole world. She was just a tester of the product. And I meet her regularly and she explains how she's working on this product. It's really fascinating. So let's, it'll be hard to understand her, so I'll keep the closed captioning on.
Communication is a fundamental human need, and I think it's also a basic human right. I'm Aubrey Lee, I'm brand manager at Google. More specifically, I'm a namer, and it's a lot of fun to say that I'm a person.
So when she says she's a namer, her job actually is to create the Google names of products, like you look Android or Pixel, etc. It's her job. She starts with hundreds of names. It's a very complex job because for different markets, she has to test and come up with different names. So she's a professional namer. This is what she does all day long.
National namer. I had a type of muscular dystrophy that affects the way I speak. I have always loved making new friends, but when people can't understand me at first, they had trouble getting to know me. It's as if there's an invisible barrier between us. I believe technology can help bring down that barrier.
My name is Julie Catio. I'm a product manager at Google in the research team. Project Relate started in 2018 when we realized that our speech recognition technology could be improved to help people with speech impairments be better understood. Standard speech recognition doesn't always work as well for people with atypical speech because the algorithms have not been trained on samples of their speech. So we decided to create an app that would be custom trained on individuals' unique speech patterns.
We named the app Relate because of what it enables you to do.
To use the app, the first step is to record a set of phrases so it can get to know how you speak. The Relate app has 3 built-in features: Listen, Repeat, and Assistant. Listen transcribes everything you're saying in real time.
So I have a custom voice model now. And
Repeat repeats what you've just said in a clear computerized voice.
that's kind of hot chocolate.
Hot chocolate.
Ah, gotcha.
Thank you.
Assistant connects directly with your Google.
So now we can see she can walk to a retail experience, talk to the barista, order a hot chocolate, and she's able to move around the world. So these are examples of how we look at societal problems to solve it besides all of the commercial purposes. And with that, I want to actually pause and close this off since we're really well over time, and just give you a flavor of how AI is dramatically changing the world. And this is one of the most exciting. What I showed you is just the tip of the iceberg. We're still in the very early stages of developing this technology, and it has to be done in participation with all of you, the whole world. It's not one company, it's not one small group of people. And you'll all be using it, giving it feedback, trying it. But much of it is also open source, which means you can build on top of these things. So all of the models that we built, so Gemini, for example, we haven't yet released the APIs, but soon you will have access to it as you can develop the applications. Actually, for the Pixel, you can do it. We have development kits. You can build apps using Gemini Nano or for phone app, for example. So you will all be part of this vast ecosystem that I'm expecting over the next 10 years that will use the different kinds of capabilities. And we'll absolutely need AI to solve so many of the problems in the human condition. Because even with all of this progress, it is still kind of a sad fact that more than half the world's population still does not have basic economic security. They might have a job, they might make a living, but it's not enough to get. Or take food, for example. The planet makes enough food for all of us to eat, and yet it's tragic that tonight 975 million people in the world will be hungry because there are a lot of systems not in place for the food to reach all those people. So there are lots of problems. So today Bhaskar Bhatt was saying that 300 million people in India are forced to have open defecation. And how do we solve for that? There's lots and lots of problems like that. And with AI, we have a hope of accelerating it. But it's not simply AI. It also needs a lot of NI, natural intelligence. It needs superior NI. And that's why I'm looking at a room like this. I might have another 10 years in my life to work on these kind of technologies before I quit. You have 60 left ahead of you. And I hope that you will all play around with this technology, adopt it, imagine, dream incredible things, and solve many of these problems in the world. So even as you feel nervous, even as you, in your mind, have this picture, I invite you to have a certain mental attitude. Larry Page, the founder of Google, would always tell us, he said every time there was a technology platform shift and it made us nervous because it was disruptive, he would say, be uncomfortably excited. Be uncomfortably excited. And that's my invitation to you about AI. Get ready to be uncomfortably excited. With that, thank you very much. Thank you for hosting me back here. Thank you. Thank you. Turn it back to you.
Okay, so now we'll start a Q&A session. So if anyone wants to ask any questions, they can.
Oh, do we want to do that? It's quite late. Are you sure? People. Yeah, I'm okay. I mean, I'm not leaving anywhere. I'm staying here tonight, so I can stay. I just want to be respectful of their time.
Okay, so if anyone wants to ask some questions.
Let's do a show of hands. How many of you want to do a Q&A? Right. So 8, 9 people. So it looks like a lot of people want to leave. So yeah. So why don't we say it for 10 minutes or so? 3, 4 questions. Yes, ma'am. Yeah. Give the mic to her. Oh wait, there's a fireside chat with alumni? And I kept them all waiting? I am so sorry, I did not. I thought this was the last session. You should have told me this before. This is, who are the alumni?
All your friends, sir.
I'm so sorry to keep you waiting so long.
Yeah, so Harish is there. And
Harish, yeah, Selvaraj.
Professor Ramkumar is there.
Oh wow. They were all waiting for their session.
No, they were also listening to you.
Okay. I am mortified. I'm so sorry. And I just went.
have them on
Okay, let's give them the stage then. Let's get them up there. Come on, let's not keep it waiting. Sorry, Selvaraj, I had no idea that was the agenda. You're patiently waiting. Rangarajan, I keep calling you Selvaraj, right? The other person is Selvaraj. Yeah. Okay, I'm sorry, Rangaraj. Sorry for that.
That's fascinating.
Harish, please take the stage. Oh, it's just 2 of you?
I saw like a couple of those videos with Gemini last time. So one thing you may want to also address is like how is it going to impact the jobs of the future?
Yeah.
Talk
Let's see if they'll ask the question, but have a seat.
So, is it possible to have all the classical music of the last 400 years into the AI?
Yeah.
Start composing?
Yeah.
Better than Beethoven or Mozart or Bach?
We don't know if it'll be better because it's not reached that stage, but maybe in the future.
It can have good
Totally, yeah. Let me see if we can do any demo of that. You're already doing that.
Yeah, I'm sure they are doing that.
What's that?
If you want, you can be seated.
Yeah, I will, yeah. I'm just trying to pull up a demo. Who's moderating it?
Good evening, guys. So welcome to Vincendo's technical domain. So we'll be starting shortly without any ado. So I would like the alumni to kindly introduce themselves with their designation.
Hello everyone. We'll begin the Q&A session. We will take one question per person with two follow-ups max. I will introduce our distinguished alumni. So first up, we have Dr. Hari Sharma Krishnamurthy from the batch of 2008. His groundbreaking research in the field of electrical and electronics engineering has earned him the respect and recognition across the academic community. Please give him a big round. Next up, we have Ms. Dr. Sembian R. Rengarajan from the batch of 1971, professor at California State University, Northridge, USA, for his outstanding contributions to the field of electrical and computer engineering. A big round of applause. And last up, as you heard, we have Mr. Gopinath Kallayil from the batch of 1984, BE Electronics and Communication Engineering, Chief Evangelist for Digital Transformation and Strategy at USA. Please raise your hand for whatever question you have and we'll pass on the mic to you.
Hello, myself Kalai. I study electronics and communication. I have a question for the panel. Question is like we are seeing a lot of improvements in AI. A lot of things are going on. It's going really good. And I want to know, since I study electronics and communication, what can I contribute? What can I do? What if, in case if I want to do a startup, what should be my focus to accelerate AI so that in future like I have like good market? And so what should I focus on? That's my doubt.
So Kalai, you remember the first slide that I showed you? Yeah. Do you remember what I said? You know, when he said, someone says, "What should be my AI strategy?" He said, strike that off and said the question should be, "What is your strategy?" So I would start with then saying, okay, you want to be an entrepreneur, do a startup idea. What is the problem you're trying to solve? I would start with that. It may or may not need AI.
May or may not need AI. First, start with the problem, and then trying to make sure that there's a good market. You solve a big problem for human beings. You're willing to pay for it, then you have a market. And people have found incredible markets in things you'd never have imagined. Including water, really free. Someone figured out that you could bottle it and brand it and flavor it. And they created a whole market. Right? Or my extreme example is how someone took a patch of land in Scotland. It was wet, it was not usable for agriculture. They put some holes in the ground, told someone, take this white ball and keep hitting it till you go to the white ball and keep doing it 18 times, and created a whole sport called golf, and it's a multi-billion-dollar industry. See, even when humans don't know, that's what I mean by, what are you trying to solve for? You will want it, you pay for it, then try to solve for it if AI is relevant. That would be my advice. I suppose saying, let me use AI, where should I apply? Flip it over. The problem is, there's thousands of problems that actually can use because AI is too much. You can see it, Rangaraj or
Yeah, I think what Gopinath said is a good point. So if you create an app, it does something. Then you look for what kind of areas, what kind of consumers can use that. That's one way to go about it. Or let's say you are going to create an app, or let's say diagnosing some particular disease, or then you work with a physician or a biologist or somebody. So like that, if you are going to do something with, collaborate with somebody, then you can come up with, okay, here I have a tool. What can it do for that particular what? So there are two ways of approaching it.
So the closest to what I got in AI is I'm married to an AI scientist. So I think so that way, I mean, kind of thing, so she had to work. So she works in energy trading. So but because of that, I have been thinking like how do we make use of AI? But I completely agree with him I do not want to use AI just for using it, but I'm trying to look at, like, for example, in power conversion system. For example, even data centers, like AI will use a lot of energy. So you will need to have data centers that can actually process all this information. Some of the issues that data centers have is because they are, you don't want, like, how many of you will be happy if, let's say, Gmail goes, there's a Gmail outage for one entire day? Will you be happy? No, right? So because of that, that's one thing. When I was briefly at Google, I was told, like, no matter what, you have to make it very highly reliable and available in terms of the power, right? So some of the solutions that we are working on is to use machine learning to help estimate the life of electronics. Where something is about to fail, we can actually say, hey, it's going to fail in another 4 months, so that we can get the inventory ready, and after that 4 months we can actually replace that, rather than, let's say, changing it every 7 years, 8 years, which consistently happens in such cases. So I completely agree with that. Basically, I would encourage you to first think of how are you going to, what are you doing which AI can help speed things up or enable certain things, and then.
If I may add, in the last 5 years or so, there are lots of papers in IEEE Explore in electrical. The machine learning has been applied, neural network, deep learning, and there are so many variations. So a lot of applications are based on problems which have a lot of data. So creating a model. For example, if you have a commercial code for computational electromagnetics, an extremely time-consuming process to create data. So if you rely on conventional techniques which use, for example, some optimization methods such as genetic algorithm, particle swarm, there are a whole bunch of techniques like that. They're all compute intensive. But now you can create less data, a good predictive model with AI, neural network, variations of that. But then you can solve much bigger problems. So there are a lot of different variations, and if you look at IEEE Explore, you can see it's really mushrooming.
So I going through his presentation, which was very fabulous. I really thoroughly enjoyed your presentation. I felt, the first thing is I felt as though I am a corporate person, which was so nice of you to make me corporate. The other thing, what I did not know what AI can do so much. Thank you so much for bringing it. But I have only one thing. See, so much of AI has come. Then where is the scope for me? Okay, let me tell you a simple example. The first time I meet my wife, right, I like blue color. So look at my wife. She is first time meeting me. I am meeting her for the first time. So I wanted to get from her that the same color I like. She also should say. But if whatever she says, suppose she says some other green color, and I like blue color. Now, in the first interaction, first question itself, it gets bizarre, right? Okay, we don't get along, something like that, right? So, the question, whatever I should have put to my wife is, I like blue color. Don't you? Is it the right question or not? When I say I like blue color, don't you means I'm forcing her to like blue color. Right? Suppose if I wanted to ask her, Annie, tell me which color you like. If she says green, I don't like green. So then the next question I cannot build up. So what I want you to, what I'm trying to impress you is, though AI can do many things, but the question what you put is still left to you. Right? Here, your creativity comes into existence. That's what I feel, right? So, for example, Ram, a tall guy. Every tall guy comes into there. Right? So, the question, so that means to say, you have to do an empathy study of the situation, write the correct thing, and then get the best out of the AI. So, AI is a very powerful tool, provided your question is right. If you give a damn question, it will spit damn answers. So we don't match, right? So that's where still there is a lot of need for you guys. Creativity. How do I present it? So sir beautifully showed a golden duck. Yeah, I used to give a problem statement. I am part of design of IIT Kanpur. So the first assignment I give to all students is design your own cup, where in which the top cross section and the bottom cross section should not be the same. It should not be circular, and try to draw 50 different varieties wherein the similarity should not be more than 30%. So now I have defined the problem clearly. So now it's a fight between you and AI. How do you get best out of AI? And if I want to make it a little more tougher, I say, okay, all those designs what you make should be manufacturable.
With recyclable material. Excellent.
So it's basically still there is a lot of things, and AI is the next level. But the first question should be done by you. Whatever sir talks about power, you have to define it properly such that AI can give you something.
Yeah. On the mic back. But before that, I want to answer. If you want to know the answer, it's Krishna Kumar, right? Yeah. Ram Kumar, right?
Yeah, Ram.
The Ram Kumar family, the answer is blue here, yellow there. Favorite colors, yes? Got that. Yeah, I nailed it.
So it was the first meeting was disaster. She says, oh, she went offensive. How can you dare tell me that I should like blue? I like yellow, she said. So then I was puzzled what to do next.
Yeah.
Go ahead.
On the mic.
What are the hardware limitations that Google faces while developing AI? Like recently, I see many companies working on AI accelerators in hardware. Apart from that, is there any limitations that Google faces, where we can actually work on?
Yeah, there are several actually. So one of the things that has delayed the availability of AI till this point, even though theory has been around, was just the lack of compute power. It's called compute. The chips that are needed to run many of these AI, especially generative AI, the right side of the brain, are limited in supply. In fact, there are only two companies who make them. One is NVIDIA, which makes GPUs, and then Google makes TPUs. And pretty much everyone is forced to them. There are other companies like Intel are working on it. So just the basic hardware is limited for that. So that's one limitation. It's also very expensive. So let me give you a sense of scale. If you go type in a question, like tell me the best vegetarian restaurants in Trichy on Google search, and type the same question into Bard, it's 25 times more expensive to generate that answer within Bard. Okay, which is part of the reason why Bard, that's experimental, it's not fully rolled out, etc. All these companies are, or you use ChatGPT, they charge $25 a month, I think, for pro version. It's very expensive. And all these technologies will bring down the cost. So that's a problem to solve for. How can you make these computational less compute intensive so that it can be less expensive? And the minute you try to do it on a mobile platform, you hit another limitation. So even Gemini, the one I showed you, the version that's available for mobile phone is much more limited because it's hard to run at the same scale on hardware. So that's another hardware problem to solve for. How can you make AI capabilities on a mobile device? And soon you'll have it on other kinds of wearables. There's two ex-Apple designers who have a very small device. I forget the name of it. It doesn't even look like a computational device. It's in your pocket that you wear it. Yeah, it looks like a dongle. So there's lots of those kind of form factors. And the third thing to worry about if you're in hardware design is energy consumption aside. These new technologies are very energy thirsty. So if we think the world's need for energy is going up, it's going to actually get even worse. You guys may not realize this, but every time you go watch a YouTube video or send an email or do a search, it is generating activity in a data center somewhere, and that's consuming energy to run the computation, energy to cool the heating devices down. So that's another thing to solve for. Can we run AI and give solutions by consuming less energy? Lots of problems like that have to be solved for. Exactly, yeah,
going
yeah.
to be 5 or 6%, 5 to 6%.
Yeah. Yeah, Harish is an expert on it. He and his wife too.
Yeah. They do these trading for cryptocurrency. They consume a lot.
Correct. Yeah.
Question that, yeah, go ahead.
All right. I think Kalai, we should pass on the question, right, so that others can ask.
Yeah, yeah.
Thank you, Kalai.
You can be louder. Just ask.
Sir, as we see an example of a deepfake used inappropriately nowadays in social media, that a video of a woman was posted inappropriately. So does Google is working on a tool that verifies is it AI generated, like fight against AI to AI itself, that if the video is there. Many times from WhatsApp also, a family sends a video and they are not able to recognize it is a fake or it's a real. Thus Google is working to fact check the video that it's AI generated or not. Because there is a platform on it. It's not being
Yeah, yeah. What's your name?
Prabhat.
Prabhat, yeah, yeah. So anytime these technologies are developed, Prabhat, there'll always be bad actors who will misuse the technology. So as all of your engineers here to remember that when you develop technology for greater good, which is what you'll be willing to do, somebody's going to misuse it, and therefore you have to put checks and balances. So it is true that many of these tools, you can create fake images, unauthorized one, or use copyrighted material to generate answers. This is one of the reasons why Google has not released many of these tools I showed you. It's still not available for commercial use. You can play around with it. It's experimental. And that reason is we don't believe it is ready to be put. Like Fenaki I showed you. Others are doing it. I can't control them. But at Google, for example, Fenaki is only available for experiment because we have to put checks in. So one of the things we're doing is when we build these models, like the image generation one that I showed you that did the duck or the raccoon, etc., those models are trained only on copyright-free material. So we don't violate copyright right in the beginning to begin with. Second, if you try to go type in, I can do raccoon, etc., but if I type, say, take Harish's photo and then create image, it won't do it. Those tools will not work with human likeness. That's built already in because of these dangers. Especially you cannot import someone's photograph and do it. Third, the images are watermarked, which means there is a little signature in there. You won't be able to see it, but we can detect to see if it is authentic. So if we give you the license, you create an image, it'll be approved, legally vetted, and it'll be watermarked that it came from you. In this way, when people send each other, if we don't find the watermark, we know it's not a legitimate image. And we can block it and prevent it. So we already do it for music. So in YouTube, people record videos, they'll take someone else's music, put it up. You cannot upload it. The system automatically detects and says, this is copyright music, you can't use it, and the video does not get uploaded. The same kind of guardrails we put in place for images, video, etc. Yes, so Google is working on it. But there is no guarantee that every company out there is going to work with things like that. So there will be these things floating around, and other companies have to put protection. The same thing like what we do with viruses, right? Viruses travel. So we have antivirus software. So we'll soon have anti-deep fake software, AI powered, that'll give you some degree of protection, like your family.
I guess that's where the government regulations can also play a part. In fact, the European Union is much more, rigorous than U.S. government, for example, with how the technology, is misused or how we can stop the misuse of technology.
Yeah, in fact, if you're interested, what Rangaraj said is absolutely true. Three days ago, the European Union passed what is the most strictest set of laws around how AI can be used. But even with all kinds of laws, there will be people willing to buy part. We have laws that says you should not manufacture, consume, distribute cocaine. Just to use an extreme example, and yet there's enough cartels and things out there. Same thing will happen. We'll have these laws. Many of us will abide, but it takes a tiny group of people to say, good. Especially there are countries out there that will live outside of this. We have no control over it. So they can expect state-funded actors actually to do a lot of damage in this world. That means it gives opportunities for all of you to go back to Kallay's question. That's a problem to solve for. Build AI systems that can protect the rest of the world against bad AI. Okay, so I'll repeat the question. Let one of the panelists answer it. Maybe Ram Kumar can. He might be closest to it. The question for the audience, he says, what is India's stance on AI development, especially the government of India, and what is the role of India in AI development, right? Yeah.
Yeah, now we have been associated with a lot of mission projects of Prime Minister's office. A lot of things are working on AI. To be very blunt with you, MP elections was won by BJP using AI. They knew the data, they understood the data, they understood the customer behavior, everything was done, and that's how they could spin. Otherwise, think of it, a party which was at 50-50, now they come absolute majority. Right? So now, AI is
2016
very
elections. What directions did?
AI is very powerfully used. In India, AI will be... Here the interesting part is there is more amount of digitization going on and there is more amount of population. So there is a huge set of customer behavior. So I can understand the customer. Today a lot of companies in India, they knew, okay, there is a flood in Chennai, the next subsequent diseases are going to be this. These are the medicines to be loaded in the pharma shops, and this is what is there, and here is the need for so many people to go around. It's all AI driven. India is very powerful using. This government is very powerfully using. So you are there in the race, you are there.
And I don't know how many of you read this article. I think Rohit Sharma, you all know, most of you. I think they are heavily using that for cricket as well. So there in the US we see for
Baseball.
American football and baseball. But here it seems in cricket also they are using AI a lot. Like there are specific analysts looking at all the different patterns. So
Any other questions?
So before we move on to the next question, I would like to introduce our additional panel as well. So Dr. Dr. Janakarajan Ramkumar of the batch of 96, professor at IIT Kanpur. His outstanding research contributions in mechanical engineering and design inspire us all. Thank you, sir, for giving your time to be with us.
Guys, I know you have been enjoying the Q&A session, but due to time constraints, we won't be entertaining any follow-up questions. So I hope you just keep in mind so that everybody gets a chance to ask questions. I will continue with the question, please. So guys, we just have 20 to 25 more minutes. So no follow-ups, just the questions, just one question per round. And let's keep the question and answer session short.
because director ma'am is waiting for them. So we need to wrap it up. Right?
Show called Shark Tank in the United States. I don't know whether it's okay. So there are very simple ideas people come up with, then market it. People in the Shark Tank helps them, and eventually they become millionaires. Some you can't. It doesn't have to be high tech. It doesn't have to be AI. Think of a nice idea which a lot of people can use.
Other questions?
I think overall, not just in this field, so there is a growing culture for entrepreneurship, and good ideas are always welcome everywhere. So I see a lot of progress even in these fronts. So I think if you have a good idea, I mean, sometimes what worries me is I've seen in the US like some certain companies just that their leaders are able to speak properly. It doesn't have to be technically sound product. Even those are getting funding, so I don't know how long that will continue. But if you have a good idea, you will find ways to fund. But just make sure that you have some ways of um, realizing whether that concept is good. That's why it's important to have good mentors. It could be your professors, it could be uh, alumni, like there are great people from the industry here. So please make best use of that, and if you have some idea, please bring it in front of them so that you can trust them because they have already achieved a lot. So they are not going to steal your ideas, but many others it's very much possible. So that's what I would suggest.
Marketing guy.
Your objectives, what tools you have, that you want.
So of course, in drug invention, drug discovery, AI is being used a lot. In fact, there has been tremendous advancements in these fields. So it is very much possible somewhere we may slip into some of these, but you know, the field of mathematics is going in a very interesting way. I don't know how much of course, I'm sure, well, I'm an engineering professor, but I'm sure mathematicians are doing great. Just that, like, you know, things like the older problems, like Fourier series and all that, so it is becoming harder and harder to come up with certain problems to work on and advance in these, like, in a lot of sense. But I'm sure at some point we end up having stumble upon certain interest.
Problem definitions AI will not be giving. AI will be giving solutions. Right. But for this millennium, 6 problems or 7 problems has already been defined. To work and then solve these problems. And it is interesting. I know you guys are much knowledgeable than me. Many a times what happens, they add a error factor or an assumption factor. That will be a number. They will not be able to justify why did they add that number. Right. So it will be something like that. So problems AI will not be able to give. Solutions I told you the first time itself. You have to tell question for which multiple answers are there. There AI comes into it. Right? And multiple answers are there. You come into consolidation, AI does it. AI cannot give a problem for you to solve. It's not a book.
Much of scientific research, always what question to ask. So that's the most difficult thing, the basic scientist. So what's the question? What's the hypothesis? So then you try to find an answer to that. That may take years of experiments or computational solutions. So what do you have to do?
There are
Those are cases where the problem is what do you want to answer?
declared, right? Millennium is declared. You have to solve the problem. The world is moving towards sustainable development goals, 17 of them. So there, everywhere, if you see energy is one thing which is very much talked about. Energy leading to carbon footprint. So today we are looking at more and more energy efficient devices. We are, as he rightly said, we are looking for high computational devices with almost zero power. So there, electronics comes in a very big way and material comes in a very big way. So there is a lot of need to revisit all the materials, whatever we have been doing. See, when we had this UPMEC, whatever applied mechanics is taught to you in college now, when you go to the minuscule level, micro level, all these, the G factor itself is gone. And now what happens to the other formula, whatever we taught? So we have to relook into it. The material has a better future and there is a need for revisiting it. We are not only looking for miniaturization, we are also looking for smarter materials. Okay, in that case, materials has a bright future.
The next big technology is going to be quantum computing. So in fact, IBM is in the forefront right at the moment. In the next 6 years or so, 6 to 10 years, you'll see computers with tens of thousands of, or even millions of more power than the present day computers. Use transistor. These are exponentially increasing computing power. So they are saying that the present day computers, what it cannot solve in years or even lifetime, those can be solved. So there's going to be a big revolution.
Okay, every question that you all asked so far has to do with AI. On this panel, you have 150 years of professional experience, 200 years of life experience on average. So I've cherished a couple of questions outside of AI about life and career or profession. If you have to ask, I would encourage you. One hand. It's about life, but I have a question for AI. Life is a yes. Go ahead, Vic.
Right from the time of industrial revolution, this has always been the case. So whenever new technologies come, they replace certain segments of the society. For example, self-driving cars. In fact, self-driving trucks. So that's going to replace all the truckers, get rid of their jobs. So what the US government is thinking is have special training. There are always going to be new jobs coming up. May not be the same thing that you did, but people have to be trained. So, if you look at the past, that's a give you an idea of what the future is going to be.
One of the issues that I think of is the reverse issue. In the US, typically there is access to calculator even during exams. We let them calculate. Here, even when I was taking my AITRIPL and now JEE mains and all that, I guess you cannot take the calculator. That's right. So we had to calculate complicated math even during that time. But what I see in the US is that let me ask the question 12 plus 13 equals take a calculator. And then if I tell the answer in let's say 1 second, it's answer, right? Wow, how are you able to answer that? So now I have a concern about probably you can do that. So can this cause, yes, there will be knowledge at your fingertips, but is it really making people a little dumber? And let's say when there may be some issues happening, is that something that we need to be worried about?
I'll answer yet all the time. So in terms of job, it is true that more jobs will get created, but there will be newer kind of jobs. Just to give you actual numbers because I'm not making forecast is that with generative AI, global economy will somewhere between 4.4 trillion. McKinsey analysis done by Google. McKinsey. A large number. What is it? It is UK economy, which means with AI we are going to add whole UK economy. When you add a whole economy, so there is going to be this. But you're right, they will be highly skilled. Much like due to the web, we ended up with people like web designer, data scientist, fabric. There will be some jobs that Raghuram was pointing out that has been of every single. Do it by hand, what we do with machines. When we do it with man, we did mud huts. Or that we do with machines, we can do 100 stories. Okay, same way with textiles. So it changed. So the people who are disrupted, either on their own account or societally, help them learn. That's what society does. Found them, tell them, we just don't let them. So that is bound to happen. We retooling them, giving them the education to upskill, go to a different topic. My favorite example is at the turn of the century, the way video used to be. Go to a physical store, bring video, take it home, watch it and give it back. The company in the US was called Blockbuster, the most popular. They had 95,000 employees. That model was replaced by Netflix, which said, we will mail it to you. Keep it as long as you want. Then Netflix said, why even mail it? I can stream it to you because of bandwidth. Now, everybody wants it. The question to you is, you want to stay with live streaming entertainment? You want to go back to the old model of driving to a store? Nobody's going to work for it. What happened to the 95,000 people who sat in the stores and played low-end jobs? Probably they've gone on to other more interesting purpose. Maybe they work YouTube now. So society moves on. There will be no denying the pain, but there are ways by which it will. You had a question? Oh, the dumbness. So it is true that certain skills we will lose, but we will learn completely new skills. One of the skills humans are losing is geographical orienteering. When we were in Trichy, we didn't have maps, we didn't have no phones, we didn't have Google Maps, and but generally knew the direction how to get around town, how to go from Rockford to Barwa Bazaar to that ice cream shop, and if you turn direction, you would know. Now no one has. You just enter it and you just let the system guide you. Is it a loss? Yeah, it's a loss. Do you care about it? But other skills, okay, I never get lost. I can go anywhere on the planet. It's given me super skills. I go to Croatia, I get a rental car, and I don't speak Croatian, and I'm from Zagreb. I'll type in, I want to go to Beach on the beach, 200 miles away, or kilometers away, and I arrive there precisely on time, directly to the bed and breakfast I'm staying at. So it has made me super capable around the world. Still, I didn't have that. Earlier, I might have needed a guide or a traveling. So I'm a better off. I think I will choose a technology-enabled world. And the same thing with calculating any other skills.
Probably the next generation may not even write. They will all just dictate and then the computer will do that or do this job or the commands will be oral. Or sometimes even that may not be the case. You just think and then the brain waves will do that. There are a lot of research going on. And,
telephone number, you're outdated. My son used to call Siri and then tells the name and something. Immediately it calls. He does not even type, as you rightly said. He doesn't do that. So he says that I'm outdated. And he's in class 8. One last question. Let's give it for a moment we say good. So now we give it to all girls. Yeah, go ahead. Quicker, fast. First of all, you should understand whose problem are you solving? Is it your problem or is it somebody else's problem? If it is somebody else's problem, you have to understand the problem. Right? And India is a country where outbeaten everybody in population. So many problems to solve. The only thing is first get out of your room, go down, identify a segment of people, right? It should not be your uncle, aunt, your batchy, not those people. Really identify people, go talk to them, and you will identify umpty number of problems are there. Anything you can solve. Nothing is saturation. I will try to just give a simple example. My friend, my school day friend, who is around about 45 age of mine, he decided that he does not want to work but still want to run an entrepreneurship. So he decided that he will take care of the dogs in a dollar colony. So that means to say you will go to the house, well, madam, I will take your dog for 2 hours of walk and I will drop you back. So for which he said, I am going to charge you 10,000 rupees. Like this, he picked up 40 houses. So what is the charge he makes? And what is his responsibility? His responsibility is only to take a dog walk. Over a period of time, he has 100 employees working with him. He has become an entrepreneur. He has solved somebody's problem. No investment, absolutely zero. Right? So you have to identify a problem. And then you try to solve the problem. Technology is a bazaar, big word. So don't try to get carried away. Okay? So understand the problem. And even now in India, we have the same problem. Many of us have a pet dog or a pet cat in our life. So when you go on vacation, what do you do with them? You can crucify. It's a business. So sit down. So you should identify a problem, right? One last question, whoever it is. Yeah. Because, okay, so he's so harsh. Go ahead.
Interesting question. After I graduated, let me try to be brief. I went to IIT Kharagpur for a master's degree. That's when I studied electromagnetics, which I started liking. Generally, when you are an undergraduate, it's supposed to be one of the hardest courses. People try to stay away from that. But it takes a lot of understanding, enjoying the math, and, appreciate that, the physics behind a lot of that, to start liking it. So then when I did a PhD in the same area and continued to work on antennas and electromagnetic over the years. So there are a lot of problems. In fact, many of my consulting work has been spacecraft antenna research group for NASA Jet Propulsion Laboratory. So there are a lot of, every time there is a new spacecraft, there's always demanding specifications, new theory, sometimes new antennas, and it's a lot of mathematical work, but it's enjoyable. And likewise, the ground system also, we have large antennas, one of them, for example, 34 meters, and it goes over 90 degrees of scanning, anywhere from zenith to horizon. Imagine such a large structure made up of thousands of panels. But due to gravitation, these things get distorted, and that can affect the electromagnetic performance. So we came up with an innovative technique for an example, the problem that we were able to solve. So this, the huge reflector with things in the order of less than a millimeter, distortions at different locations. So we were able to determine what it was, and then somewhere there was near the receiver, there was a small flat plate. We introduced known distortions to compensate for that, and it worked amazing. Sometimes there are really simple solutions that are possible. You don't have to think very complicated. Sometimes it has to be a lot of mathematics and very involved. But that's enjoyable. Yeah, I think the key thing is, they say lifelong learning. These are perhaps some of the student outcomes they talk about, So it's not just having a lot of knowledge, but to start enjoying the learning process. So once you do that, when you go through your career, the type of jobs you do, the type of problems you solve, they keep changing, periodically. So 20 years from graduation, what you do is probably very different from what you did in the beginning. So you have to have an agile mind and, be willing to solve new problems, complicated problems. Try to learn, work on it. Sometimes a lot of hard work. So,
what I can quickly say is, so I was mentioning it earlier as well. In my third year here, I started working with one of the professors in the electrical engineering department on research on electronics for electronics, and that really interested me. And then another thing was one of the pragyans, like there was a professor from abroad who was talking about, of course, this research, and after that, towards the end, he was explaining how good it is to get a PhD and how you'll be like Einstein and so forth. So that was very inspirational. So with all these combinations, I said, okay, fine, I should try and get a PhD. And then once I started, I really liked analog electronics and also power electronics. And then had some very good professors whose courses I took. And what I can say is that right now I'm designing power and energy systems. And then my researches are driven through my experiences in the companies that I work with, GE, Schlumberger, Google, and Ford. So I work in all these four domains. Um, you know, so through our experiences, you can take little bit things. So don't deny anything. And let's say there's one more thing quickly I want to add is entrepreneurship, yes, it is very important, but look for the problem. Like, let's say if you find a problem that you can solve, yes, that's a great thing, but it may not be great to just say, yes, I have to become an entrepreneur. So, you may take some time to learn stuff. So if you have a great idea, yes, but otherwise you don't have to say, I have to become an entrepreneur. You can work in a company, gain some experience, or you can go to grad school, so you gain some experience. Larry Page and Sergey Brin, they were graduate students in Stanford. That's when they got this idea, but they could never complete their PhD because they were so busy after that. So, you never know where the inspiration comes in, but just be a little bit more open-minded, and then we can get a lot of things done.
So I was very successful in my first year here at IT. I was nearly the top of the class, and after I got the ECE, very quickly I sunk to the bottom. Something. I, I was self-aware that I was the least smart person in the class, and I almost failed. But it also gave me the awareness that going into deep engineering was not really my destiny or talent or my passion, which is why I left a lot of my classmates who ended up with careers like to get a master's or a PhD. But I found that the two skills I was good at during the time, not great at talking about stochastic model of communication or digital signal processing, but I was very good at communication and leadership. So I gravitated towards it. This is why I went to business school, got an MBA. Still love technology, but at a certain level where I could understand it and talk about it. So that's a career I pivoted to. Even at Google, when it's a tech company, I don't work on the deep. But other smart engineers do that. But I learn about it, I can express it and demystify business audience. That has become my superpower. So this is a question of finding it. There's nothing to be embarrassed about it. But knowing what your strengths are and what your limitations, then pivoting around it. There's a role for everyone. One with extremely smart brains, and the one without that.
I can briefly talk about one of the scientists in the US by name John Lederman. He was a Nobel laureate in high energy physics, and he was the director of Fermi Lab in Illinois. After his retirement, he used to go to a lot of colleges, especially many of the undergraduate students used to talk about the virtues of science, what a great thing it is. And in one of these forums, an undergraduate asked him a question. Dr. Lederman, it's easy for you to say all of that, how great it is. You are a Nobel laureate, you have achieved everything. I'm just an average B student. I never hope to do anything great. And then his answer was that when he was a student, he was just a B average student. He was not one of the super smart students. So he went to City University of New York, but he used to be friends with a lot of top students, A students. And he kind of followed them when they went to graduate school. He went to graduate school. And of course, during the World War II, they did military service and then came back and eventually went for a PhD. 5 years after his PhD, he said, not as bad. I'm probably as good as some of those people. And 10 years later, he was doing world-class science. So his advice is, you don't have to be brilliant. A lot of times, brilliant people tend to be flaky. What needs to be done is hard work and passion. You have to be passionate about things, work hard. But even if you don't achieve, anything big like a Nobel Prize or something, you are going to do great things, great, talk about it to your family. That's that.
To me, REC Trichy taught only one thing, is negotiation. Nothing more than negotiation. I negotiate with time, I negotiate with money, I negotiate with technology, and I negotiate with my students. Right? Negotiation skills are something which is taught in this institute, which is not taught on books. Even you go to the chaiwala, you impress him to get you the best tea. It's negotiation. The skill of negotiation is something which is taught in this campus too. Did 18 courses, that's what you need to graduate. I did a formal negotiations course, business schools teach it. I did it with Richard Shell, top negotiators. If people were to say all the money I spent at business school, I were to pick only one course, I would pick, besides what I learned at REC formally, Meet negotiations, I also learned formally. It is the one skill that I use most consistently. I've used it for business deals and for my company. I use it for salary. When you get a job, most importantly, you will use it with your spouse, your kids, and your children. And that will determine whether you are happy in life or not. So, which is why, buy yellow saris. With that, let's close this off. Thank you very much.